billahi minash shaitanir rajim. Bismillahir rahmanir rahim. I'm Bashir Ahmad, your business maths teacher. This is my second video lecture. In this lecture, I shall try to explain how to solve a linear programming problem. For this purpose, we are taking the question number 1 of the practice set 17, page 277. The question is to maximize the objective function p is equal to 25x plus 35y subject to the problem constraints 2x plus 3y less than or equal to 15, 3x plus y less than or equal to 12. These are the problem constraints, and x is greater than or equal to 0, y is greater than or equal to 0. These are also the constraints, although these constraints are not given in the problem, but it is understood that these constraints exist. X and y are non-negative constraints or decision variables. To solve this linear programming problem, we follow a few steps. The step 1 is to determine the feasible region. What is feasible region? After constructing the feasible region, we will be able to understand what a feasible region is. We draw the graph of the inequality 2x plus 3y less than or equal to 15. We write down its associated equation by replacing the inequality sign by the equality. 2x plus 3y is equal to 15 is the associated equation of the given inequality. We find its intercepts. For x is equal to 0, by putting x is equal to 0, we have 3y is equal to 15, then dividing by 3, we have y is equal to 5, which is the y-intercept. Now, to find the x-intercept, put y is equal to 0, we have 2x is equal to 15, then dividing both sides by 2, we have x is equal to 7.5, which is the x-intercept of this linear equation. We draw a solid line through the point 0.5 and 7.50. When x is 0, y is 5. When x is 0, y is 5. So this is the point 0.5, and when x is 7.5, y is 0. We move 7.5 units along x-axis, and y is 0. This is the next point. Joining the point A and B, we have drawn the solid line representing the equation 2x plus 3y is equal to 15. Now, using 0, 0 as the test point to check whether this inequality represents the half plane containing the origin or not containing the origin. We have to putting x is equal to 0 in this inequality. 2 into 0 plus 3 into 0 less than or equal to 15. We have 0 less than or equal to 15, which is a true result. This true result indicates that the inequality 2x plus 3y less than or equal to 15 represents the half plane containing the origin. The half plane containing the origin. Now we take the second inequality, 3x plus y less than or equal to 12. Now we draw the graph of the second inequality, 3x plus y less than or equal to 12. Its associated equation is 3x plus y is equal to 12. We have just replaced the inequality sign by the equality sign. To draw the equation of this linear, to draw the graph of this linear equation, we find its intercept. Put x is equal to 0. We have y is equal to 12, which is the y-intercept, and then put y is equal to 0. We have 3x is equal to 12, or dividing both sides by 3, we have x is equal to 4. So 4 is the x-intercept. We draw a solid line through the point 0, 12 and 4, 0. 0, 12. When x is 0, y is 12. C is the point 0, 12. And when x is 4, y is 0. The next point is when x is 4, y is 0. So D is the second point. Joining the point C and D, we have drawn a solid line representing the equation 3x plus y is equal to 12. Now using the test point 0, 0, we have 3 into 0 plus 0. Putting x is equal to 0 and y is equal to 0, we have 0 less than or equal to 12, this is a true result. This true result indicates that 3x plus y less than or equal to 12 represents the half plane containing the origin. This true result indicates that this inequality represents the half plane containing the origin. The region which has been shaded red in red color is the common region to both the inequalities 2x plus 3y less than or equal to 15 and 3x plus y less than or equal to 12. And this region has been bounded by the x-axis and y-axis. This region is known as feasible region. The common region OAED bounded by the coordinate axes, that is x-axis and y-axis, and the given constraint is the feasible region. The step 2, to find the corner points. All the corner points, that is the point O, the point D and the point A, are known except the point E. To find the point E, which is the point of intersection, the point E is the point of intersection of the associated equations 2x plus 3y is equal to 15 and 3x plus y is equal to 12. We solve the equations 2x plus 3y is equal to 15 and 3x plus y is equal to 12 to find their common point of intersection. So multiplying equation 2 by 3 and then subtracting from it equation 1. 2x plus 3y is equal to 15. Multiply equation 2 by 3, we have 3 3s are 9, 3 1s are 3 and 3 12s are 36, and then changing the sign, we have minus 7x is equal to minus 21, or x is equal to 3. Putting this value of x in equation 2, we have 3 into 3 plus y is equal to 12, or y is equal to 12 minus 9, or y is equal to 3. The required point is 3 3. The step 3 is to compute the value of the objective function. The step 3 is to compute the value of the objective function on the corner points. The corner points are 00403305 and the objective function is 25x plus 35y. For this point, the value of the objective function is 0. For this point, the value of the objective function is 100. And for this point, the value of the objective function is 180. And for this point, the value of the objective function is 105. We see that the value of the objective function is maximum at 3, 3. So in step 4, we find the optimal solution. Since the value of the objective function is maximum at 3, 3, so it is the optimal solution. That is, P has maximum value for x is equal to 3 and y is equal to 3. This is at the end of this video lecture. For further practice, you are requested to solve question number 2, page 278, and question number 1, question 2, question 3, and question number 4, page 279. Thank you.